applications of quadratic functions and models. So what we're doing here is going to do application problems, but with quadratic equations. So these applications are all going to require quadratic equations to solve. So there's our first one. A farmer wishes to enclose a rectangular region. He has 120 feet of fencing and plans to use his barn as one side of the enclosure. Let X represent the length of one of the parallel sides of the fencing. So we're going to do a rectangle, and then one side is going to be the barn itself. So we don't need fencing on that side. They want the two parallel sides to be X. The key here is what do I write this side as? Well, the total, like of all the fencing, the total of this guy plus this guy plus this guy is 120. Since we have two X's here, we decided this side is going to be 120 minus X, or 120 minus 2X. So that's what that side is, right? It's 120 for the whole fence. Subtract off both X's, and you get what this side is. So this is 120 minus 2X. Okay, so now that we have that, let's move on. Determine a function that represents the area of the region. So we got to come up with the area of the region. So it's a rectangle. So area is this length times width, or base times height. So area is going to be this guy times this guy. So X times 120 minus 2X. So this is my area, right? So area of a rectangle is just length times width, or base times height. So it's just this side times this side. So there's my area. If they want a function, I could simplify that a little bit. I get 120 minus 120x, minus 2x squared. So that is my function. Area equals 120x minus 2x squared, and you can see it's a quadratic. What are the restrictions on x? So just saying, like, what could x not be an answer to? Because it's a quadratic, we're probably gonna get two answers. What's some bad answers we can't get? Well, really, all it mostly ever is you can't have a negative number. We can't have a negative side of fencing. So x has to be greater or equal to 0. Can't have negative fencing. Okay, let's see. Let's graph the function in a view that shows both x-intercepts and the vertices of the graph. So now we're going to need a calculator. It wants to graph it in a view window. So x equals, I'm type in our function, 120 minus 2x squared. Now I'm doing the normal window right now, like standard viewing window. So let's just see where that takes us. Something like that. Well, I get both x-intercepts. I just don't get the y-intercept. So how high should I go? I'm gonna go to about 120. It's the only number I see there. So let's go 120. Highest number I see. I don't actually have an answer yet, so let's try 120. And you can kind of see it right there. So that looks good. I might even go a little higher just so I can get a little buffer, but that looks fine. So there's my graph in the cursor viewing window. So I was doing C, it looks like this. Now it's a little, those x-intercepts look like they're decimals, so that's not gonna be nice, but there's my graph. Figure at 41, so here's figure 41, shows a cursor at 18 and 1512. Interpret this information. So keep in mind when we do that, right, this is the x value, and this is the y value. What's our x value and y value on our equation? X, like in here, x is the length of a side. Actually, of the parallel side to be exact. And y, what I get out of this is my area. So for D, this is saying when my side length is, 18, what are we doing, meters? Feet. 18 feet. The area is 1,512 feet squared. So that's what that point tells us. If we decide to go a side length of 18 here, our total area would be 1,512. E, what is the maximum area that the farmer can enclose? So we're looking for the max area. We're essentially looking for this part right there. That'll give us our max area. So we have a graph, so let's use it. Now I just realized this graph doesn't match on because I forgot an x. So it's 120x, I'm going to put second, insert x minus 122. So now let me hit graph and see what the graph looks like. And that graph is not nearly as good as the one I had before. So let me go to 0. So So right now I can't see anything, right? I mean a little bit right there. So I'm gonna change my window. Let's go from like -5 to like 30. And it looks like they go much higher than 120. You can barely see this. Let's go like 500. Actually, not even 500. What's up here? Right? Up here we had up to 1500. So I'm gonna go 2000. So let's go 2000. Because from the earlier point, it would already got to like high. So 1500. So now I can see this side. Well, I can't see the other side. So it looks like I have double my x value. So let's go to like 60. My x max. So here we go. I guess I could just use the one they gave us here, 2,000 and 100. What do I get? Look at that. Look at that nice graph. So let me change this picture. So now it looks like this. Right. Okay. Now we want to find the max, so we're going to go second, calculate maximum. So around here's my max. Let's go, but you can't just guess. You can't just guess by tracing. You're gonna go to the left of their max, hit enter, and then go to right of where your max should be, and then hit enter. Now it's gonna search between these two values. We're gonna hit enter, and let's do that. And our max is gonna be 30. Right, if you round 30, x is 30 at 1800 feet squared, which is higher than this one. So what's the max area of the farmer can enclose? If we're doing E, max area would be 1800 feet squared. By the way, that happens when the side is a length of 13. Was that 13? 30. So it's a little context there, but that's how we do it. Right? We draw a picture. We set up an equation that fits the picture, and then if they want us to find the max, we just graph it and find the max. So let's do another one. Find the volume of a box. So in this one, they actually give us the picture. So down to that, determine a function that expresses the volume of the box in terms of the original sheet of metal. So they want us to find the volume. Well, volume in general is this length times width times height, right? It's area of the base times the height, which is right here. So my volume is going to be, just multiply all those together, 5 times x minus 10 times 3x minus 10. So there's my volume. What are the restrictions we can place on x? Just like last time, this is a side of a piece of a box, so it can't be negative. So x has to be greater than 0. Oh, so it can be 0. It can be a box if your x is 0. So x has to be greater than 0. Actually, this one's a little more fancy. I just noticed, like, this side, that's actually not right. Right? This side has to be greater than 0. That side can't be negative, or this side can't be negative also. If we solve it, we get x has to be greater than 10. Right? Because again, this side can't be negative. So you set that side greater than 0, and then you solve. X has to be greater than 10. I could do it here also, but that's a smaller value. If I set that greater than 0, I would get like 3.5. This covers both of them. So x has to be greater than 10. C. If the specification is called for the volume of such box to be at 1435 cubic inches, what should the dimension of the original box be? So they're saying our volume should be this. So we're going to substitute this in for my volume, and we're going to solve it. Now, how do we solve that? We use a calculator. And I guess you can solve by hand, but it'll take forever. So we're going to use our calculator. Right. This time they gave us the information what the volume was. They gave us the picture, and it's like, hey, find the volume. Well, the volume is just multiply them together. And now they say that we want the volume to equal 1435, so you set that equal 1435 and you graph it. So we're going to graph both of these things. 5 times x minus 10 times 3x minus 10. And then over here, 1435. Now, my window, I'm probably going to keep it around the same. -5 to 60, because I could see my sides here. I need to go 1435. 2000 is already bigger than that, so I'm gonna graph it here. I think it's good. So there's a picture, and then there's our answer there, where they intersect. So I'm gonna go second. That's a little small. 1435. Why am I missing a value? Oh, let me graph it again. I was like, that doesn't look like 1435. It should be up here somewhere. So you get something like this. I always like to draw the picture so we know what we're doing. So it looks like this. Now there's two x-intercepts. There's one right here. That's going to be negative, so that's not a solution. And then we have this one that's positive. That's the one we want. Right, so we want the positive answer because, again, our x, you can't have a negative side. So all we're going to do is find the intersection of this one right here. My mouse is not working with me right now. There we go, that guy. Second calculator, intersect. And then now you can move left and right. If you're not sure where you're at, it tells you right here where you are. We're at 30 somewhere. But here's a little help hint. Press up, and you go jump onto the other graph. Like, oh, I'm right there. Let me move left. Now you don't have to be right on. You just want to get kind of close to it. And hit enter, enter, enter. And it finds the intersection for you. X has to be 17 inches. Right. And now it gets us 435. So there we go. That's a problem. Let's do another one. Pythagorean one. A piece of property in the shape of a right triangle. That's an unusual piece of property. Let's draw it. Here's a right triangle. The long leg is approximately 20 meters longer than twice the length of the shorter leg. So we have two legs here. Let's make one shorter like that, and then this one's the long one. So the longer leg is approximately 20 meters longer than twice the shorter leg. So twice the shorter leg plus 20 meters. So like that. And then they say the length of the hypotenuse is approximately 10 meters longer than the length of the longer leg. So here's the longer leg, and then we're 20 meters longer than that. So we're like 2x plus 20 plus another 10, which would give us 2x plus 30. That's hypotenuse. Find the length of the sides of the triangular lot. So you want to find the length of the sides. Well, this is a right triangle, so there's one famous formula we could use, which is a squared plus b squared equals c squared. Remember, in that formula, c is the hypotenuse, so it's opposite the right angle. So this is my hypotenuse, this is my c. A and b don't matter. So we get x squared plus 2x plus 20 squared equals 2x plus 30 squared. So now we have to solve this. Now we could solve this by hand. I can multiply this out. 2x plus 20, 30 times 2x plus 30, and then 2x plus 20 times 2x plus 20. Or we could use a calculator. Now this one, I think I'll tell you right now, I tried a little bit earlier. Let me type them in. And the graph wasn't the easiest to find. So that's the standard, 0, 0, you can't see anything. So you go, okay, let me go a little bigger. So let's go to like, well, I could do negative, but honestly it doesn't matter. We're not going to have negative answers here. My domain will be x greater than 0. So let's go to like 100. And then let's go to, I don't know, 1,000. See if you can see anything. So I can see that. And I think they intersect right here, but that's a negative intersection. I don't want that. I want the positive intersection. I don't know. So it's going to get a little ugly. So I'm going to go higher. A lot higher, it looks like. What was that? 10,000? Let me go 30,000. So you can see where they cross there. So that's the first graph. And here's the second graph. And you can see they kind of interlock around here. So we could do it this way. Find the intersection. You got to be handy with the calculator. Let's find my intersection. I had to go really high up there. Intersect, intersect, intersect. And they cross at 50. X equals 50. The y value, that's where it happens at. So x is 50. You want the sides. Now keep in mind, what the question was, find the length of the sides of the triangular lot. So 50 is just one of them. It's this one. I got to find all of them. So this would be 2 times 50 plus 20. So 2 times 50 is 100. So 120. And then this one's the same thing, but plus another 10. So this would be 130. So my sides are 50 meters, 120 meters, and 130 meters. So those are my answers. Now, if you want to solve by hand, you can multiply these all out. You would actually go x squared plus, what is that going to be? 4x squared plus 80x plus 400 equals 4x squared plus, that's 120x plus 900. Then you can set equal to 0. Now some things actually cancel out, and it's actually not too bad. Negative 40x minus 500. And then you could have factored that, and you would have got x minus 50, x, I think, plus 8, I believe it is. So you get x equals 50 and negative 8. But negative 8, you can't have negative answers. So you will get the same answer either way. So use the calculator or factor it. Let's do one more. Hitting a golf ball. A golf ball sits so high that h in feet is given by in t seconds by this. So keep in mind, we always want to know what we're talking about. T is seconds. Right, so that's the thing. That's our x value when someone plugging it's in seconds. And h is height in feet. So t is time, h is height. What is the initial height of the ball? So the initial height means that's when time equals 0. So for a, we're just going to plug in 0. So I get negative 16 times 0 squared plus 60 times 0. And actually just get 0, because we haven't hit the ball yet, so it's still at the ground. So 0. How high is the golf ball after 1.5 seconds? Again, notice they're giving me seconds again. Well, they're giving us seconds, so we're plugging in t. So h of 1.5 is negative 16 times 1.5 squared plus 60 times 1.5. And I'm just going to type that into the calculator. Get that out of there. We want negative 16 times 1.5 squared plus 16 times 1.5. We get 54. So 54 feet. 54 feet high after 1.5 seconds. Find the max height of the golf ball. So to find the max height, we're just going to graph it and find the max. We could do that, or we could find the vertex by using the formula x equals negative b over 2a and then plugging it in. So both ways to find the vertex we want, to find the max we want. It's going to be a decimal, so I'm going to use the calculator and let's graph it. So let's delete these we did last time. I'm going to go negative 60 x squared. We don't have a t, so let's use x plus 60x. I probably want to reset my window, so I'm going to go zoom 6, zoom standard. Something like that. And you can kind of see a little bit of it, but we really can't see the max. I want to go much higher. Now, first one, we got 54 feet over here, right, when we tried 1.5 seconds. So I think my x min, x max is good. It's going to go higher. So we're all the way up to 54, so let's go to 100. Let's give myself a real buffer. So right there, right, you can barely see it. I mean, it looks like this. Let's find our max. So second, calculate, trace. Let's find the maximum. There we go. All we have to do is go a little left and roll right a bit. Right now we're at the 0. So go right. Around there's the max, but we won't actually find it. So go a little left, hit enter. Little right, hit enter, hit enter. And then there's our max. It happens at about 1.9 seconds, but the max is 56.25. So I'll put a little point here that says 1.9 and 56.25. So our max height, which is the y value, is 56.25 feet. And there we go.